Good morning, good evening, good afternoon, ladies and gentlemen, on this big blue marble we call Earth. My name is Bill Rivers, and I am the host of Tracerco Talks, and I'd like to welcome you to today's edition. Today, as always, we have a really great guest, Mr. Patrick Hayes. Patrick has been with Tracerco for over 18 years, has held global as well as various positions within Tracerco. Patrick, welcome to the show.
Man, fantastic, William. Happy to be here.
So, you're a reservoir guy. That's your current title. That's your current position. That's what you currently hold. So, from my point of view, the only thing I really know about reservoir, is about basically it's just basically hydrocarbons and gas that's basically just trapped underneath the surface, right? And then companies spend tens, not hundreds of millions of dollars trying to find these different types of reservoir, plus moving the equipment, plus moving all the people in the position to go after these reservoirs. So, Patrick, kind of walk us through where does Tracerco kind of fit into this? What is Tracerco doing? And basically, what is overall, what do you guys do?
You bet. Well, I appreciate the question. It's pretty interesting nowadays how life cycle management's kind of changed in these reservoirs, where things have gotten pretty complex. There's been a lot of learning along the way, and exploration companies are really looking at the full cycle of production of oil, water, and gas. And nowadays, they even have the introduction of using reservoirs for carbon capture as well, or using it for tertiary recovery mechanisms, with government funded stuff. But when it comes to the subsurface, there's so many wonderful technologies out there when we look at trying to diagnose different problems that particular basins have and challenges in extracting reservoir oil from the reservoirs, or gas from these reservoirs. So there's a lot of challenges out there. There's a lot of different techniques, and tracers fit into a number of different parts of the reservoir life cycle, which is really pretty interesting. And our focus really is the use of chemical tracers to diagnose and produce reservoir characterization in reservoirs using chemical tracers, not radioactives. There's some benefits to using chemical tracers, and in their different physical forms, they can provide a lot of different information, all the way from exploration exploration wells, all the way through to the enhanced recovery and tertiary recovery that gets applied.
So let me take a step back. You kind of mentioned something that kind of intrigued me. So you talked about problems, right?
Yeah.
So there's a problem out on the reservoir. So why are they calling Tracerco? Why are you guys coming out to the site when they're having an issue with the reservoir? What makes you guys unique and special that you can, help the customer?
Absolutely. William, the tracing side of it, and where Tracerco historically is has really shined, is that we're there to measure the difficult to measure, right? And most of the things that are happening in the subsurface are measurements related to something else. You know, seismic data, for example, is a measurement taken at the surface. They take those sound waves and relate it to what's in the subsurface at different depths. But when you start looking at granularity, and trying to relate characteristics, rock properties to actual production, that's where tracers come in. If you want to measure the actual production or movement of a specific produced phase, right? That's where we shine. That's where
Well,
chemical tracers really shine, and it is the ability to measure specific phases from the reservoir.
so when you talk about specific phases, are you talking like it moves from a gas to a solid or a gas to a liquid? What do you describe what you mean by phases? Talk to me a little bit more about what you mean about phases.
You bet. So, say in an unconventional well, if you wanted to measure oil production along the lateral at different stages, right? That's something that can be measured and quantified using a oil chemical tracer, right? If you wanted to only measure the water and the water production from specific phases or quantify recoveries of completion fluids, you would use a water tracer, and a tracer that will only be produced with the water phase, right? And if you're wanting to identify liquid hydrocarbons or oil, if you will, being produced from a reservoir, right, you would use an oil tracer. And a gas phase tracer is going to be a tracer that's produced by the gas. So you can measure specific phases of production. The physical form of the tracer is going to determine if it's quantitative or qualitative, right? There's different ways of applying chemical tracers, and those ways of application will determine if it's qualitative or quantitative. Under most circumstances, under steady state conditions, a solid tracer material is going to be a qualitative answer. It's going to be a flag on and a flag off. Is it present or isn't it present? Under specific circumstances, when it's attached to a completion, right? You can use things like transient studies to make it quantitative. But under steady state conditions, it'll only be qualitative. If you use a liquid tracer, for example, right, in many circumstances, that liquid tracer is going to be a quantifiable measurement, looking and evaluating cumulative recoveries, right? So the physical form of the tracer, its chemical properties are really going to determine, am I tracing the water phase, the gas phase, the oil phase? And then the physical form applied is going to determine if it's a quantitative answer or just a qualitative answer, right?
And so just so going back to quantitative and qualitative, so you're saying the customer determines what they want, or is it
Absolutely.
more? Okay.
Well, it's good. What's going to determine it is where the return on investment comes from, right?
Okay. There you go.
You may be in a situation where you just need a flag on, flag off, right? Like a tow flow. All I want to know is uh, if all of my wellbores contributing. Man, a binary answer of yes or no is fantastic, right? If you want to know, hey, in my multilateral well system, do I have water breakthrough, right? And where is that water breakthrough coming from? That's another binary answer under steady state conditions. That's fantastic, delivers a return on investment. But if I want to know where's my best producing locations along the lateral, right? And how much time do I need to invest in drilling? Maybe I need to do more geosteering. Maybe it really matters how tight I put that well bore in my desired location of the reservoir, right? My target interval. Um, but maybe it really doesn't matter. Maybe I can be wild with it and drill fast. They're drilling wells 4 miles long now. So if you can increase drilling efficiency by just a few percent, you're going to save millions across a development.
Wow, I didn't realize that in depth. I mean, that's completely fascinating. So basically, you can help a customer determine like how they're going to drill, where they're going to drill, what the well's looking like, where the best production is, where the least production is, right? You can tell it's a plethora of things. So going back to these tracers really quick, are all the tracers that you use, are they unique to Tracerco? Are they specially formulated? How talk to me a little bit about the tracers. Tell me how does that get from point A to point B?
You bet. Tracerco does hold some patents when it comes to tracers, tracer applications. Some of those are unique to the quantification of hydrocarbon tracers in unconventional applications. Um, so there are some unique things there. I think one of the things that really sets chemical tracers in the spotlight is the amount of research and development done to back them up. That's where we shine. the investment in that research and development, understanding the chemical properties. However, it takes some pretty specific compounds to measure phase specific things, and especially to survive the reservoir environment. It's hot. A lot of these reservoirs may be up to 250 degrees C, so up to 400 degrees. Selecting the right tracers that aren't going to be eaten by the bugs, aren't going to be affected by the pressures, right, and aren't going to thermally degrade under those high temperatures. It takes a little bit of science, right, and having done that testing really makes a big difference in understanding the tracer responses that you see. In the end, if we don't see a tracer, we want to be able to say with confidence that, oh, it's not there because it hasn't arrived yet. It's still in the formation. And on the flip side of that, if we say, hey, we're seeing this communication pathway between wells, be it injectors, producers, or horizontals that are on a pad, if we're seeing this amount of communication, we want to be able to say, yeah, we're confident in that answer, right? And it's the research and development that gives you that confidence.
So when you're talking to a customer and the customer says, yep, we want to go with your company, Patrick, we want to go with Tracerco, we think it's one of the, we like what we hear, you have the research, you have the development that's all backing you up. So what's the process? Is there a form a customer fills out, or do they come to you and you sit down with your research team and say, okay, this is what we're seeing in the formation, this is the data that we have? How do you go about collecting that information in order to select the right tracer? How does that process work?
You bet. So, I kind of touched on it earlier. It's about return on investment, right? And it's really going to depend where the customer is in their development process, right? They've acquired a field. They may be a step out, a new area that they're going into that they're going to explore and try to understand the best production, the best development practices, all the way from target zone through multi-well pad development, well spacing. Maybe eventually they have plans for injector producers. So they're going to do some kind of EOR, be it a water flood or a CO2 flood or a WAG, a combination of the two. So it really depends where they're at. But the basics behind tracer selection themselves is what's the ultimate return on investment. We can plan a program from initial drilling all the way through to final development, or it can be select at one or two stages where there's some learning that can be applied to the whole development of the field. So as far as information we need to select the correct tracer once that return on investment's been decided is going to be based on reservoir temperature, the amount of dilution that we're going to be dealing with, because these tracers, they're incredibly stable, right? They don't have a half-life associated with them. They're not a radioisotope. So we need to look at what's the lifetime of the project, right? What's the goals and objectives first, then lifetime of the project, of course. And then how much dilution are we going to be dealing with? Those are the three primary bits of information that we have. Of course, yeah, we have a data sheet that we want to record things on so that the communication pathways are clear through the planning and implementation of the project. But we need some basic parameters to understand. When you get into some of the longer term projects that are 2, 3, 4, 5 years, and they involve tracing gas, there may be some differences in how fast different gas compositions move through the formation. So then we might want to go into it a little bit more and look at gas composition, do some core testing, things like that. But generally, it's not needed.
So I guess the next question that kind of leads me to is, so how do you get these tracers into their system? How do you get it into their process? I mean,
Oh man,
injection, just walk over the side of the hole, dump it in the hole? Like, how does that all
yeah,
work?
yeah. No, there's, I talked a little bit about physical forms of tracers and how they give you different answers, and really that physical form of tracer is going to talk a lot to the delivery, right? How we're going to apply them. The nice thing about uh, most of the tracer materials that we have is that they can be project specific and applied for that specific goal and objectives. Uh, for example, if you want to talk about injector producer relationships, so an ER application, a common misconception is that's an injection that's done as a continuous injection, almost like a chemical additive, if you will.
Right.
But that's not the case. It's actually injected as a pulse. Why is it injected as a pulse? One, from an application perspective, it's much simpler. We do the injection under steady state conditions for those applications because we want our tracers going where the injected fluid and gas is going under normal conditions. Then on top of that, pulses provide a really efficient way of early identification of breakthrough, things like that, a pulse injection. If you look at a stimulation for an unconventional well, right? We don't disrupt fracking operations. It's added during the completions operations. And then finally, if you're interested in inflow, long-term flow assurance, long-term looks at water breakthrough, things like that, where we can attach tracers to a completion, we can do that at the manufacturing facility. So really all of the tracer applications don't interfere or require intervention. So 95% of the time, there's no intervention required for the application of tracers or disruption in the process. So it makes it fairly easy. There are some differences in applications depending on what that goal is, right? Do you want solid tracers applied to a completion, or are you trying to quantify production in a horizontal? Or even the conventional guys nowadays, there's been such a melding and a melting pot of ideas and knowledge gained from conventional completions and unconventional, where you can hardly separate the two. There's tracing opportunities now for conventional wells that weren't there just a few years ago. And then on unconventionals, unconventional reservoirs, they're utilizing conventional applications to remediate, clean up, refrac. There's just so many new applications out there that are developing as the technology in exploration and production continues to innovate.
That's incredibly interesting, Patrick. It truly is. I have a just quick question, just kind of summarize it just a little bit. To me, it sounds like you're looking at overall like the whole life cycle of the from start to finish, right? That's what Tracerco is involved with, right? You find a customer, you actually work as a good partner to help them get the maximum, out of that well they have drilled. Is that kind of a correct?
You bet. So, in what you've said there, I mean, we're involved in the full life cycle of the reservoir and its exploitation and production. No doubt about it. Um, we increase efficiency, right? And we by increasing efficiency, you increase production. And there's just so many different ways to do that. If it's from evaluating a completion method, right,
Right.
to establishing best practices, to looking at injection chemistry, we can do remaining oil saturation measurements so that you can better understand what your ultimate recovery is going to look like when you change your injection chemistry, or if you apply a different type of EOR. We can do that from an injector to a producer as well as a single well test. Really, the opportunities are almost limitless when it comes to um, enhancing the reservoir's recovery. But the real beauty is with chemical tracers is there's no intervention required, which means it's low risk and it's a fairly low cost now that analytical capabilities are into the parts per trillion, right? So you don't need a whole lot of tracer, where just 10 years ago you needed 10 to 100 times as much. So the cost of the application's low. The risk to the operator is low. I'm not sticking a tool down in the hole that I can get stuck, right? That could cost millions. I'm not disrupting their operations while doing it. So there's just a whole lot of advantages and numerous applications along the way, from that initial well that gets drilled all the way through to tertiary recovery, end of life cycle.
So before we end this, give me a good example. Come on, I always love stories. That's one of the big things. I love stories. I like hearing about how at Tracerco we went out and we helped a customer. Tell me something. Give me something. Give me a good one. Come on, end it on a high note, Patrick. Come on,
On a
tell me
high
something
note.
good.
So what you're saying, what's the biggest return on investment I've seen in the last year or two for a single operator?
Absolutely. Come on.
Okay, well, I'll put a couple of them together here. I can probably think of one for almost each category of frac uh, through to tertiary recovery. So some highlights. We were able to identify a barrier between multi-well laterals in a new basin that was being explored. And what that was able to identify were these horizontals that were next to each other. And when I say next to each other, I guess different vertical planes. Um, but these wells were completed together. They threw the kitchen sink into the completions. It was massive. When I looked at what they were doing and spoke to the engineer, I thought, my God, we're just going to see a milkshake here, of communication between these wells. And when we quantified the communication between the wells, the only locations that truly had communication were where there was facies changes between faults or formation changes that could be identified in both wells. Both wells were fantastic producers, but they were isolated from each other. So from an evaluation perspective, uh, it wasn't shared production, which was fantastic. The
Oh,
operators' oil recoveries and potential oil recoveries were much higher than they expected. Um, and it proved that they had a layer in between that was a real barrier, right? Another one, as an example, we had an operator that had to spend a significant amount of money on a wireline operation or intervention because half the lateral wasn't contributing. The decision was in the multiple millions to run that intervention, and we were a very clean and concise way to show that the production was only coming from half the lateral. And when you're making those big decisions to do interventions and workovers, having a clear, concise answer that says, yep, this is what we got to do. There's no question marks. It's not an if or a but. When you go to your management and say, hey, we got to spend tens of millions to clean this well out. If you've got some concise data, that says, yep, this is what we need to do. It's a clean cut decision. That really makes a huge difference. And then last but not least, we did an EOR project. And with EOR, it's a lot about rebalancing the field,
Right.
where, how much you're injecting where, and how does that relate to the producer. Um, and by actually shutting in a water injector and a gas injector, they were able to increase production by several hundred barrels per day. So huge, huge recovery. Paid for the study within a month. Pretty massive. So that's my high note.
I love it. I love the stories. I mean, they were great. I love the fact that, based on the technology and the service we offer, we were able to help customers out. And that's just what we're all about, right? We're there to help the
Absolutely.
customer in any way, shape, form, or possible. Well, hey, Patrick, we're out of time, and I appreciate you coming on. Ladies and gentlemen, again, my thanks go out to Patrick Hayes for taking the time out to come and talk to us a little bit about Reservoir. If you'd like to get in touch with him, you can find him on LinkedIn, or if you'd like to reach him direct, you can, reach him through his email, which is patrick.hayes@tracerco.com. If you'd like to talk to me or follow me on LinkedIn as well, or even reach out to me directly, my email address is william.rivers@tracerco.com. Ladies and gentlemen, we appreciate your time and thank you very much.